Hi, welcome to the tutorial on machine learning models with Python. I am Arnab Chakraborty from Updegree. In this video, we are discussing errors, residuals and regularization. So we shall go for the errors and residuals at first. We know that statistical errors and residuals occur because measurement cannot be exact, never exact. And it is not possible to do an exact measurement. But it is possible to say that how accurate a measurement is. So one can measure the same thing again and again and collect all the data together, and this allows us to do the statistics on the data. So what is meant by errors and residuals is the difference between the observed or measured value and the real value, which is unknown to us. So now let us go for more discussion on these errors and residuals. A statistical error is the difference between an observation and its expected value, which is based on the entered population. So remember, the errors will be calculated on entered population. That means not on the sample but on the entered population. Okay. Usually values for the entered population are unobservable. That means the population might be having a big size, so it is very difficult to calculate the mean age of the population or the mean height of all human beings and so on. A residual is the difference between an observation and its estimated value, that is the mean height of randomly chosen sample of human beings. So residual will be calculated on samples, that is the subset of the population. Residual sum of squares, in abbreviated form it will be called as RSS, also known as sum of squared residuals, that is SSR, is the sum of the squared of residuals. It is a measure of discrepancy between the data and the estimation model, and it is used as an optimality criteria in parameter selection and also in case of model selection, that which model will be suitable for this particular data set for the predictions. In a standard linear simple regression model, we know that yi is equal to a plus bxi plus epsilon I. What is a? A is the intercept. What is b? B is the respective coefficient, and xi is nothing but the input variable value, and epsilon I is nothing but the error. So RSS is equal to sigma I is ranging from 1 to n, that is a sigma I square. So we are taking the residual sum of squares. So that is nothing but we are going for this sigma I is ranging from 1 to n, yi minus alpha plus beta xi, and the difference has to be squared here, where alpha is the estimated value of a, beta is the estimated value of the slope b. So estimated means it will be deviating from the actual. Minimizing the RSS function and is a building block of supervised learning algorithm. So we are supposed to make this RSS as minimum as possible. That will indicate that my model is becoming more predictive, more accurate, and it is going to give us the correct outcome. And in the field of machine learning, this function is referred to as the cost function. Now we shall go for one graphical example explaining the residual. So when we perform simple linear regression or any other type of regression analysis, you get a line of best fit. That means multiple points will be there. Say in case of scatter plot, along the x-axis we have plotted some variable, along the y-axis we have plotted another variable. So independent variable will be plotted along the x-axis and dependent variable will be plotted along the y-axis, and some dots will be obtained, and that plot is known as the scatter plot. So whenever we are having this regression line, that is the line of best fit, so sometimes the data points or the dots sometimes fall exactly on the regression equation line, or they might be scattered around, and which is the most probable thing. So a residual is the vertical distance between a data point and the regression line. Each data point has one residual, and they are positive if they are above the regression line and negative if they are below the regression line. If the line actually passes through the point, the residual at that point is also 0. So let us go for one graphical example for the better visualization. So here is the line with the equation, that is y is equal to 0.8x plus 5. 5 is the intercept and 0.8 is the coefficient of x. Let the points are x1 y1 is equal to 1 comma 5. Now in the x, if you put 1 here, so it is coming around 5.8, but here we are getting this y1 as 5, so it is going for 5 minus 5.8, So the respective residual for this particular first point, that is the x1 y1, will be minus 0.8. Now in case of x2 y2, that is the 2, if you consider for x2, so if you put 2 here, so if you go on doing this calculation, so 2 into 0.8, so it is coming around 1.6 plus 5, so that will be 6.6 here. So now 7 minus 6.6 is equal to 0.4. So that is a residual for this point number 2. Now if you go for the x3 y3, that is the 3 and 6, you can find if you put 3 here, so it will be coming around 2.4 plus 5, so it will be 7.4, and here we are having this 6, so it is minus 1.4. So here you can see we have also denoted the same using these graphical expressions. So now what is happening, you can find that here we are having those points which are actual, and here we are having those points which are estimated. So here we are calculating this residual, here the residual is negative, here the residual is positive, here the residual, that is the point number 3, x3 y3, is also negative here. So in this particular graphical example, we have explained that how these residuals can be calculated pointwise. Now we are going for the topic, that is the R square and adjusted R square. R square determines how much of the total variation in y, that is the dependent variable, is explained by the variation in x, that is independent variable. So R square is equal to 1 minus sigma y actual minus y predicted whole square by sigma y actual minus y mean whole square. So that is the expression for R square. The value of R square is always in between 0 and 1. If 0 is there after getting calculated, means that the model does not explain any variability in the target variable y. That means it is too much predictive. And 1 means that it explains full variability in the target variable. So obviously our expectation will be that R square will be very much close to 0. The adjusted R square is a modified form of the R square that has been adjusted for the number of predictors in the model. Now you might be asking me, what is a predictor? So according to the definition, you can say that predicted variable is nothing but a variable that can be used to predict the value of another variable. As in case of statistical regression, the variable a quantity that can assume any of a set of values, and that is known as a predictor variable. So the adjusted R square is a modified form of the R square, and that has been adjusted for the number of predictors in the model. So it incorporates the model's degrees of freedom. The adjusted R square only increases if the new term improves the model accuracy. So R square adjusted is equal to 1 minus 1 by R square into n minus 1 whole by n minus p minus 1. Here respective R square is a sample R square value, and n is equal to total sample size, and p is equal to the number of predictors. So each and everything we have explained here, just consider this one as R square, that is a sample R square value. So in this way we have discussed what is R square and what is adjusted R square. Now we are going to discuss regularization. So overfitting refers to a model that corresponds to closely or exactly to a particular set of training data but fails to fit new data or predict future observations reliably. So now in case of overfitting, we know that for the present set of data it is working good, but for the unseen data the prediction is becoming very much poor. That is known as the overfitting. We know that whenever we consider multiple input variables for a model design, then the model can be predictive. Even if you consider more than 4 say feature variables, then also the model can be overfitted. So it is a statistical model that contains more parameters that can be justified by the data. So regularization is a very important technique in machine learning to prevent overfitting. What we shall do, we shall increase and decrease the feature variable participations, that is importances. So depending on that, those feature variables which are more decisive towards the output, so they will be having some higher value for the coefficients, and those feature variables which will be having the lesser variability with the output, so they will be having the lesser value for the coefficients. As a result of that, you can increase and decrease the importance in the decisive logic of the outcome in a particular model by using this technique known as regularization. So mathematically speaking, it adds a regularization term in order to prevent the coefficients to fit so perfectly to overfit. So we are having two kinds of functions. One is the L1 norm loss function, another one is the L2 norm loss function. In case of L1 norm loss function, minimizes the sum of the absolute difference S between the target value yi and the estimated value f of xi. So here you can find the respective norm loss function. So S is equal to, so that is the absolute differences. S is equal to sigma I is ranging from 1 to n. So absolute yi minus f of xi, that is absolute value. L2 norm function minimizes the sum of the squares of the differences S between the target variable yi and the estimated variable f of xi. So here what is happening, you can easily find here that S is equal to sigma I is ranging from 1 to n, and here we can getting this one as yi minus f of xi, and the difference has to be squared and then they will be summed. There is a sum of the square of the differences. But in case of L1 norm function, it was sum of the absolute differences. So regularization adds a regularizer, that is the RF, to a loss function. You can see the respective formula here, where V is the underlying loss function. It might be L1 loss function, norm loss function, or L2 norm loss function, and lambda is a parameter which controls the importance of the regularizer. So in this way you are finding what is a regularizer, what is a regularization, and what are the different loss function, norm loss functions L1 and L2, and different terminologies. So in this video we have discussed what is the residuals, errors, and regularization. Thanks for watching this video.